Um, I'm really happy to be here and talk about some deep neural networks. I hope it will not be boring for you. Actually, I try not to put some, like formulas or something. So, actually, let me introduce myself, first of all. I am Olgun. Okay, my name might sound strange. I'm from Turkey, and usually the people from Poland cannot pronounce my name, but anyway, it doesn't matter. Uh, I'm working for EPAM as a senior data scientist. Okay, cool. I'm working as a senior data scientist in EPAM. Um, yeah, I'm data scientist. Do we have some data scientists here? Nobody? Do we have some people who hate data scientists? Okay, cool. I'm happy. Because usually my colleagues hate me, and especially my developer colleagues hate me because actually my background is statistics, I'm not a developer guy. So usually they are saying that, so you're demanding a lot, Olgun. So you're just doing something like some formulas, some fancy things, and we are coding everything. So, okay, if you don't think like this, so I'm fine with this. I'm also happy. So, do we have someone who already did something with deep neural networks, I don't know, machine learning? 3, 4, good. So what kind of things have you done? Like, I don't know, NLP, image recognition, or? Okay, thank you for your answer. Okay, anyway, probably, it's still early. I also overslept. Anyway, it doesn't matter. So, today, actually, we are going to talk about fundamentals of machine learning. So, what is this magic? We know where those information come from. Also, I would like to show you some real-life examples. Also, I would like to point it out the artificial intelligence structure, so how it looks like. So what are the steps of these things, and so on. And afterwards, I'm going to talk about deep learning for Java, DL4J. It's actually framework for Java, as it's obvious. And you can build your deep neural networks, you can build some machine learning models using this, by using Java, on the top of Java. Actually, when you have a kind of backend which is based on Java, using this framework would be really cool. So, of course, I'm asking to my colleagues because, like I said, I'm not a developer guy, but I know the, infrastructure, not infrastructure. I know the theoretical things and I know how to build something. Of course, I can read and write a little bit Java anyway, but actually it's really cool and of course it's really fast. And you can do a lot of things using this deep learning for Java framework. Okay, and let me give you some information about me. Like I said, I have statistics background. I have bachelor and master degree from statistics. Right now, I'm doing my PhD, again about statistics. Hopefully, I'm gonna finish my PhD at the end of October, if I can manage to, write my thesis. So anyway, I hope so. And I have 6 years experience on this domain. I mean, data science domain. Actually, I would say, okay, we are in the Java conference, but I'm really big fan of R because, this is really fancy language and so on. And I really also like using Spark R, and I really love building Shiny applications using R. I'm also familiar with big data frameworks like Spark and Hive, Hadoop. Also, yeah, we have some meetup groups. Like I said, I'm from Turkey, and we already have 2 meetup groups in Istanbul. Like we have almost 5,000 members there. And also we created new meetup group in Gdansk. By the way, I'm located in Gdansk. and it's called like Troimias to Spark Meetup. And we already organized 3 or 4 events, and we are just inviting people who are interested in this big data domain or data science and something. Also, you can reach my GitHub repo and something like this. And also, I published 2 video courses on PactPub. And of course, they are about R, unfortunately not about Java or DL4J. And I also wrote a book about R, so yeah, anyway. Okay, so this will be our outline today. First of all, like I said, we will talk about the machine learning concept. So what is this? What kind of algorithms we have? What kind of real-life applications we have? Also, what's happening in this domain? How this magic happens, how it works. And then we are gonna just talk about a little bit about deep learning frameworks, what kind of deep learning frameworks we have, and especially the popular ones. Then we will just take a look at the DL4J, so how it looks like, so what we can do with this, and so how we can install this, so how we can use example library and so on. And at the final step, we will do some basic demos, like we will do some word-to-vect demo and some classification demo, and they will be so basic. So, and actually, I will try to show you something, from the IntelliJ interface. So, okay. And I think we have 4 people who already did something with machine learning, right? Okay, so how do you feel when you hear about machine learning? So it sounds like a magic or it sounds like a bullshit? So what do you think? Magic? Bullshit? Okay, cool, good ratio. Statistically significant. Okay, cool. Yeah, we can say that machine learning actually a field of computer science. It's actually highly related with statistics. And actually, I really like to say this because I'm a statistician, so and I'm sort of having fun when I'm saying this. Actually, these machine learning algorithms and techniques uses kind of statistical techniques, and also they are also based on linear algebra and calculus, of course. So what we can do with this kind of algorithms? Actually, we can teach something to the machines, right? We can give some, I don't know, objects like images, and we can say that, okay, this is cat, and this is dog. And then machine can learn this, and then say when you give it the photo, and it can predict that, okay, it's dog or it's cat or something like this. Of course, actually, as long as we have more data, so we can have better models. So this is the actually important point. Yeah, actually, like I said, machine learning is closely related with computational statistics. Also, the main thing is about, another main thing about machine learning is optimization. Because we have kind of loss functions, and actually we are trying to minimize this loss function to improve our accuracy. And also, for example, when it comes to deep neural networks, we have actually a non-convex optimization problem. We have a non-convex surface, and we are trying to find the global minimum point for this. Actually, as it's seen that we need a lot of computation power for this. And let's say if we are talking about image recognition or object detection or something like this, so we need to process those images, we need to convert those images to the matrices, because if we give the computer like an image, so it will just look at us, so what are you talking about, and it will say something like this. So we have to give the computer some matrices, some numbers. So this is the point actually. That's why optimization is really a critical point here. So let's talk about what happened recently regarding artificial intelligence and deep neural networks. And for example, you know DeepMind? That's fine. Oh, cool. Okay, you know actually DeepMind was a startup, used to be a startup, and it was acquired by Google. And of course, they saw the potential on this company, and they decided to buy it, like every huge company do. Actually, what did they do? And they taught to computer. They trained an agent, and this agent, the beat in the AlphaGo champion. And also this agent, and they trained another agent, and this agent also destroyed the chess world champion. So actually, when it comes to chess and when it comes to AlphaGo or something like this, so actually there are some patterns, and there is a mathematics behind of this. So actually, if we can learn how to play, and if a person can win this championship, so also a machine also can do this. It's just about how we are teaching the computers to do something. So what else can we say about this? Also nowadays, actually I didn't put it here, but it just came to my mind. Facebook actually released really cool deep neural networks. It's called Mask RCNN, and actually it creates some masks on the objects on the photo, on the given photo, and it actually predicts. So what are they like? If we take a photo here, and if we give this photo to this model, so it will actually create mask on all of us, and it will say, okay, person, 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 chairs, chairs, lights, and something like this. So also, there are like this Mark RCNN, there are plenty of state-of-the-art architecture. So you don't need to reinvent the wheel, right? You can use a transfer learning. There is a cool concept which is called transfer learning. So you can use really huge networks which already trained, and usually they have like at least 200 layers or something like this, really complex networks, and they already trained. You already have weights, vectors for this, and you can just change the last layers, or I don't know, first layers with your data. And if you just replace those layers with your customized neural networks, so you can use the whole structure for your own data. And then, like I said, you don't need to reinvent the wheel, because there are a lot of people who are working on this domain. So, actually they're inventing something like with a lot of effort. So of course we can also build some neural networks from the scratch, but if you have especially kind of NLP tasks, NLP problem, or some kind of image recognition problem, I strongly suggest you to use this kind of state-of-the-art architectures, and you can use the transfer learning. So actually, nowadays, this artificial intelligence is really popular, right? Everybody's talking about it. So actually, actually artificial intelligence covers machine learning. And we can say that artificial intelligence is a kind of umbrella, and it has the machine learning under of it. And also machine learning has 3 different kind of learnings. So what are they? Let's talk about them. Supervised learning, unsupervised learning, and reinforcement learning. So what are they? What is the supervised, and what is unsupervised learning? So let's talk about them. So supervised learning actually is about classification tasks, right? So for example, we talked about image recognition, object detection on the photo. And we have here classification problem. And we have some labels, right? Because we are giving the computer an image, and we are saying that, okay, it's cat. This image on the photo, cat. So we are supervising the model, right? We have some labels. So when it comes to unsupervised learning, we don't have labels. actually, like clustering algorithms and some recommendation engine algorithms are using unsupervised learning. So for example, let's talk about clustering algorithms. So, actually there is one really fancy and well-known clustering algorithm, which is k-means. Especially, let's say you are working for a bank and you have a lot of data about your clients, and you would like to create some campaigns, right? You would like to at least send some messages or, I don't know, email to your clients. And you would like to create a campaign about mortgage. So first of all, you can say that, okay, I can, I don't know, provide lower interest rate to the rich people or to the people who have tendency to have houses or something like this. Also, you shouldn't, for example, send a message to a student, who is already studying and who's not working. So for this person, so it looks like, okay, weird. So why I should buy a house? Because I don't have money or something like this. And you can cluster your customers. So let's say you have thousands of labels, and you want to create 5 clusters, like, really rich, super rich, normal, don't say poor, not rich, not so rich. And then you can send the related campaigns, related messages to the related groups. Then actually you will improve your conversion rate, right? So let's talk about reinforcement learning. This reinforcement learning actually was used for this AlphaGo agent and this chess agent. And it's based on rewards. And this algorithm does something, and then system gives this some rewards. Let's say you are also, there is one more agent which can play Doom 2. So do you remember Doom 2, like old school game? That's cool. So actually there is an agent which can play this Doom 2. So in this game, actually, there are some rewards, right? When you, I don't know, jump or when you kill someone or something like that, you are getting some rewards. So this actually algorithms, this system learns that, okay, if I kill someone, I will earn some points. Okay, I should kill someone. That's fine. And if someone shoots you, so you are losing points, right? Okay, the machine says that, okay, someone shooted me, I lose points. Okay, I should, I don't know, escape, I should run away. And this learning method is based on rewards. And this system also, creates some points and creates some optimization algorithms, like we talked, like these complex optimization algorithms. It gives you the route to follow in this kind of systems. Cool. This is actually a really good graph, or let's say image. This shows the machine learning process. So also, we talk about really cool things like image recognition, and we gave an image and like it's supposed to predict the images here, like it says that, okay, there are 30 people here and something like this. So actually, what kind of process we have behind this? First of all, we should have proper data set for this, right? We should have enough data. It's hard to say how big data we should have, because there is no like measurement for this. It's not a kind of track. Okay, if you have a stomachache, so just take this pill per day or something like that. It's not this kind of things actually, and we should have data as big as we can. So, and actually this guy is data scientist. So some developers hate this guy, and it just sits in front of the computer and it creates some fancy graphs, and no one understands what he's doing. Anyway, also he's like a grumpy guy and he's saying, okay, I don't have proper data, so because of this accuracy is so low or something like this. So what does this guy do? This guy actually gathers some data, right? Especially when it comes to real life problems, if you are not using kind of, let's say, open source data, or if we are not using some tutorials about the kind of programming languages, in real life, we don't have clear data. What I mean about the clear data. So let's say we are collecting some sensor data, right, from an engine. Actually, we already did a project like this, and we were collecting some sensor data from aircraft engine, and we had the label data, and we trained a model, and we were predicting the current condition of engine. We were saying that, okay, it's going to fail in the next 5 steps, so please take this aircraft to the mechanic guys and something like this. So in this case, for example, we had a lot of problems to have proper data. Because, you know, the sensors are a kind of electronical things, right? They can break down. So sometimes actually they cannot send the proper data. Sometimes they are sending like totally irrelevant data. Like when we have a kind of numbers like between 20 and 30, and we were just looking at, we have, you know, 9,000 or something like this. So it means that something went wrong. So we should clear our data. We should get rid of those data. And also sometimes, you know, we couldn't get data, like, I don't know, because of connection problem or something like this. And also, this means we have missing values, right? And we also should deal with those missing values. We should input them, or I don't know, we should maybe, if we can, we can exclude those rows. But actually, it's not recommended, especially if you don't have so big data set. Because, you know, each row is really important, and also you can lose some more important information. So what we are supposed to do? So we should clean the data. We should input missing values. We should deal with missing values. We should deal with outliers. And when we are sure that we have proper data, we have clean data, and we don't have like strange dots on the plots and something like this, and we can decide to type of algorithm which we are going to use. And in this case, also defining the problem is really important. So in the previous slide, we were talking about unsupervised learning, supervised learning, and reinforced learning, right? So if we have a kind of classification problem, like let's give an example from the NLP domain, right? We are trying to predict the sentiment of a comment, right? If we are trying to say that, okay, if it's positive or negative. So here also we have a classification problem. When we have a classification problem, if we are using kind of linear regression models, for example, so it would be really weird. So because it's not for this task. We don't have regression problem, we have a classification problem. So what is the regression problem? Let's talk about this. Regression problem is also kind of using supervised learning, because we have also some labels, some target values, right? So actually, this example is really good for regression tasks, actually. For example, we have some kind of data set. In this data set, we have attributes of houses, like how many rooms do they have, like how many bathrooms do they have, the floor number and total number of the whole building and building edge to building. And also we have price, a price per square meter. And then when we are if we are trying to predict the price using the attributes of this home or houses, and we have a regression problem. So we shouldn't try to use some, you know, classification algorithm. So because, you know, we cannot manage to predict the prices properly. Okay, then when we define our problem, when we decide what kind of algorithms should we use, so then we can proceed to the next step. So the next step is about training model. Also, this is actually really hard to say which algorithms should be used for, you know, which kind of tasks, because, you know, there is no best model. It will never happen, because it's really hard to say which algorithm is best for these tasks or the other task. So actually, we should try as much as we can, and then we should we should build different type of, for example, classification problems. So what we have about the classification problems, we have decision trees, we have logistic regression, naive Bayes algorithms, and artificial neural network, and so on. So actually, we should try different type of models and compare the results and compare the performance of those models, and then we should decide, okay, this one is better and this one is not good. And also, we should have two sets of data, and which are the train and test set, and we should validate our data using this test data set, because in train set, the model learns the pattern of the data, and then if you use the test set, because the model didn't see those data points before, like during the training process. If we give this test set to the model, so actually it will try to predict the kind of unseen points, like some values for unseen points. Also here we have another problems, like overfitting and underfitting. So, and comparing the train accuracy and test accuracy is also really critical. So if there's a really huge gap between the train accuracy and test accuracy, it means something went wrong. So let's say our train accuracy is around 90%, but our test accuracy is around 60 or 50 something. So it means you have overfitting. Your model overfitted, right? Because it didn't work with unseen data points. So you should do something, or you should optimize your models. You should do some kind of hypermeter optimization, or maybe even you should take a look at your data set again. Maybe you did something wrong when you were cleaning the data. And then afterwards, so of course, what we did, collect data, clean data, decide the model, and train the model, compare the results. Also, as a data scientist, we should share those results in an understandable way. So we shouldn't put like more fancy functions or, I don't know, formulas or something like this. The other way, actually, for example, in my case, so I'm training some model and I'm saving them. Also, my backend colleagues are using those, calling those models from the backend, and the system actually can predict something. Or actually, they're writing some APIs, and you can just send some requests through the REST API, and then this REST API can turn you some responses, with predictions and with confidence levels. So, so what we have in real life, we talked about machine learning, deep learning, and AI. What we have, so companies are using deep learning networks or machine learning, right? Because as you know that Google actually maybe one of the greatest company, which they are using this machine learning algorithms. First of all, they are using machine learning for everything. It's like for Google AdWords, I don't know, AdMobs, and for improving the quality of their internet search. For everything, for Google Maps and so on. And also, of course, Yahoo and Bing and Ask are also using data science algorithms. So another application area of data science, or I don't know, machine learning, actually, they're totally mixed and they're really buzzwords, so we can use whatever we want. Another application area of this domain is recommendation systems. So as you know that recommendation engines are really important for e-commerce platform, or let's say a kind of streaming platform. So for example, probably most of us are using Netflix, right? So it recommends us something like some movies according to our past behaviors or something like this. And actually they're using really cool the machine learning algorithms. Even actually, they organized a contest with Kaggle because they wanted to improve their recommendation engine, and they just organized a kind of contest, and then a lot of people attended this contest, and they worked hard to improve the recommendation engine quality. And actually, the prize was like $1 million. Actually, you know how important it is for them, because as long as they can provide better quality, better service to their clients, so people actually will continue to use those platforms, and of course they will earn more money. So also, another cool real-life application of recommendation system can be seen on Amazon. So when we visit the Amazon.com, yeah, we can just see easily the recommended products just for specific to us, right? According to our past behaviors, of course, they are using some cookies, and they know who are we, sort of, and at least they have an idea about our gender, our age range, and something. So even if even they know if you have a kid or not. So because if you just once bought something for your kids on the internet, and they can say that, okay, this guy might have a kid, might has a kid, so then let's recommend something regarding this product category or something like this. So another application area of this domain is prediction systems. So what we have here actually, we have here image recognition, speech recognition, and fraud and risk detection, and of course we have here self-driving cars, and they are using actually a lot of things here, what we talked about, and also some robots, right? Also, actually, we can say that, maybe next slide we will talk about it, that would be much better. So we talked about actual image recognition, right? So what does this image recognition do? And they're recognizing images, and they're saying that, okay, we have here some cats, or I don't know, the machine can say that, okay, I saw a guy who has a, who looks like a potential terrorist. So I don't know, also I matched that, okay, he did something bad in his past and something like this. And especially in the United States, these kind of systems are used. They are collecting data from the CCTV cameras, and then they're matching the faces with their databases, and they are saying, okay, we have a guy here and who has potential to organize some terrorist attack, or I don't know, we have a guy here who already suicided a crime, so let's do something for this. So we know the speech recognition. Actually, all of us are using smartphones. So what does this do? And actually, text to speech or speech to text, and it recognizes your voice, and it converts your speech to a text. And even sometimes, actually, I'm using the WhatsApp text to speech to text. And when I'm driving a car, I'm just pressing, and it sends some text. It converts those speech into the text, and it's actually really cool, I would say. So fraud and risk detection. Actually, it's getting more and more popular nowadays, because fraud, it's really important for especially payment gateways and also banks, right? Because when they have a fraud, or when they have a kind of not good, they're losing money, and they don't want to lose money. Also, sometimes we can lose money, so they can steal our credit card information. I'm not saying that the banks are stealing, or just another people can steal our credit card information, and they can do some shopping with this kind of things. Okay, we are running out of the time, so I will run a bit. So here actually we can see for example, on the top, on the left-hand side, this is the Spotify's architecture, and they are also using recommendation engine, and actually they're pretty good at this, and because they are using signal processing, and they are processing the signals of the songs which you already listened, and then they are providing you the recommendations regarding to those signals of the songs. They are trying to find the songs which have the similar the signal with the songs which you already listened. So we know the Google PageRank, and also in the photo on the bottom we can see image recognition, and it's really possible to recognize multiple objects on the photo. And here actually we can see the recommendation engine on Netflix. So this is actually also the face recognition, and it's pretty possible to recognize age of a person using the photo of face of this person, and even it's possible to predict the emotion. And of course, if you have enough data, so you can predict even name of this person. So what kind of deep learning frameworks will we have? And we have Caffe. Actually, it was right now supported. It's supported by Facebook. And we have Cognitive Toolkit, which is supported by Microsoft. And we have MXNet, PyTorch, TensorFlow, and Tihano. And the TensorFlow is actually one of the most popular and one of the most used frameworks. We have also Tihano, it's also quite popular. And also we have Keras, and actually Keras, I love Keras because it's a kind of wrapper, and you can use both TensorFlow and Tihano. And because TensorFlow has a kind of more complicated structure, especially for data scientists, what Keras actually, allows you to build the deep neural networks using the TensorFlow background with less complicated UI. And also it's quite flexible. You can just add some, activation functions and do something like this. It's not a kind of, awful wrapper. And we have Deep Learning 4G. And Deep Learning 4G actually, and as it's seen that it's obvious that it's a kind of Java framework for deep neural network tasks, right? Actually, it allows you to do a lot of things. It allows you to use Spark and some big data frameworks, and it allows you to use GPUs. So for actually image recognition tasks, using GPUs are quite important, because I would like to give you an example. We were trying to recognize the products on the shelf on the given image, and first we tried to use CPUs. Our training process took 1.5 days, and then we just started to use GPUs, and the training process finished in 40 minutes. So, and actually you are saving a lot of time, and you don't, in this case, you're not, tiring your system, you're not blocking your system, and so on. So actually, installation of DL4J is quite straightforward. So of course, first of all, you have to have JDK, and you can check your version of the Java of your version, of course, and you need Maven, and you should install Maven. You should have Maven on your system. Also, actually, it's quite recommended to use IntelliJ with DL4J, because it provides you really straightforward interface. And also, if you like to use the example, because there are really cool examples on the GitHub repo of DL4J, and you can just, if you have a Git on your local, or I don't know, on your remote computer, and then you can just clone this repo, and you can build your Maven, and then you can use those examples. So actually now the time for demo, small demo. Oh my God, my computer is dying. so sorry. Yeah, I had to do this because, you know, that look awful. So, and actually, this is the IntelliJ, and also this is the deep learning for Java, deep learning 4G structure on my local. As you see that, you can find a lot of deep learning examples when you go to the SRC, main, and Java. And as you see here, we have a lot of cool, let's say, examples. Let's try to do a basic classification problem, basic classification tasks on deep learning for Java. And actually, we have labeled data, and we will try to predict their classes using this. And at the end of this example, we will have a cool, fancy graph. So this is training process. So as you see here, actually, you know, because our data set was not that complicated, and then it actually managed to classify our data set really well. Let's use a little bit more complicated data. Yeah, actually here, as you see that we have a kind of more complicated structure, and it tries to classify the, actually it tries to divide those points into two subclusters, subgroups. So actually, you know, for some of them, it couldn't manage to divide properly. And also here, you can see the evaluation metrics. As you see here, our accuracy is 96%. And here also we can see the confusion matrix. It says that, and actually as you see here, just for 17 of those data points, this algorithm predicted zeros as 1. And also for 20 data points, this algorithm predicted ones as zeros. So actually, it's quite good. You know, we still have, you know, high accuracy, 96% accuracy. So also, I would like to show you another cool feature of the DL4J library. And when you are trying to build some, you know, convolutional neural networks, let's say you have a image recognition task, actually, you can see the, it provides you an UI, and you can see the training process. Okay, something went wrong. Okay, anyway, let's try this. Here we have actually, it's opened the DL4J training UI. So also here you can see your model. And even you can see the parameters on each step, on each layer. Also, in next steps, you will see the chains of those parameters. So, for example, the first step already completed, and we can see the activations, information about activations here. So also, we can just zoom in our model. So in overview also, we can see the loss function change. And we are expecting loss function to go down. And because of this, we will have the high accuracy. And if we cannot lower the loss function properly, so it means that we will not have cool accuracy. Here also we can see the parameters here. So on system also you can see the memory utilization of DL4J and JVMs. And it's actually quite cool and especially really helpful. And you don't have to follow those iterations here, because also here we have information about the training process. Right now we are in the 65th iteration, but I'm stopping it because it will take like 4 ages. So also I would like to show you one more thing, and then afterwards I'm gonna complete my talk. So actually we talked about word2vec, right? So I would like to show you really small information regarding word2vec. And actually word2vec is a two-layer neural network, and it creates a corpus from the text, and it finds the similarities. It actually creates connections between the words on the given corpus, on the given text. It shows you the similarities and distances of the words. So, for example, in this case, and we give the Sweden to the system, to the word2vec model, and it gives us the distances. It's called like cosine similar distance, cosine similarity matrix. And actually the Norway is the closest one to the Sweden word, so actually it really makes sense. Slovenia is actually really far away from the Norway. On the map is also right. So on this word2vec world is also true. And here also we can see the similarities between the words. So actually I trained the model, and I used Shakespeare's the novels. Also you can easily find them on the internet. Okay, I don't have them here. And I trained this model, and in this example we are going to find 10 nearest words to the word love. So actually I was really curious about this thing, so let's see. So as you see here, we have the 10 closest words to the word love. We have love, so probably he said that, okay, I had loved her, or I would love her, maybe. And maybe he said that, okay, I think I felt in love with her. And then maybe he said that I have loved her or something like this. And so I cannot love her because, it's Shakespeare, so he was confused all the time. And his ideas, could be changed easily. And actually, that's all from my side for today. Actually, we are out of the time. So thank you for listening, and thank you for attending. If you have any questions, please shoot.